So for number 5 here, we have this equilibrium. We can write our equilibrium constant expression. It's not a reaction. The equilibrium expression is just going to be K. Will be the BrCl squared over Br2 and Cl2. Then we can set up an ice table. So they give us the Kc. Don't worry about the temperature. But we know that this K, and the C just means we're using concentrations here. This is going to equal 7. And they give us our initial concentrations of our two reactants. They don't tell us anything about the products, and then we want to find all the equilibrium concentrations. So I'm going to have Br2, just going to rewrite this equation to BrCl. I'm going to start with my ice table. I initially have 0.05 here, 0.050, 0.050. We don't have any of that. And I'm going to do minus x, and plus 2x. So at equilibrium, I have 0.050 minus x and 0.050 minus x and a 2x. Then I can take all of this and plug that into my equilibrium constant expression. And my k is 7, so I have that there. So I have 7 is equal to 2x, that whole thing squared. This is my 2x. I'm plugging it in over here. I'm squaring it because that's part of the equilibrium constant expression. Products over reactants raised to the stoichiometric coefficients. And then on the bottom, I have the 0.050 minus x times Cl2 is also 0.050 minus x. I'm just plugging in that bottom row, 0.050 minus x. So that's 0.050 minus x squared, right? This is just, this times this is the same thing. I'm going to simplify that just a little bit. Now I have a perfect square over a perfect square. So I can take the square root of both sides. Is that where I am with this one? Yeah? Yeah? All right. Take the square root of both sides. So I get the square root of 7. I'll just rewrite it over here. Square root of 7, right, is equal to 2x over 0.050 minus x. And then I just have to solve for x. So I can multiply. So the square root of 7 is just 2.65. Right? So I'll just rewrite that. This is 2.65. 2.65, and I'm just going to multiply that bottom part over. I get 2.65 times 0.050 minus x is equal to 2x. Distribute that through, and I get 0.1325. 1325 minus 2.65x is equal to 2x. I'm going to bring my x's onto the same side. I'm going to add the 2.65x over there, 2.65x over here, and you get 0.1325 is equal to 2x plus 2.65x is just 4.65x. 4.65x, divide by 4.65 to solve for x, 4.65, and I get x, put it over here, x ends up being over here 0.028. And they want to know what are the equilibrium concentrations. So after I know x, I can just go back over here and do my 0.050 minus 0.028. And then over here is going to be 2 times 0.028. So what do I get? 0.056 for this guy, and then 0.022 for these guys. Wait, it's the same number because it's 0.050. So those are your final answers. 0.022 molar, 0.022 molar, and 0.056 molar.